Focused learning target. I can graph and analyze dilations, reflections, and translations of radical functions. A square root function. Roots function contains the square root of a variable. Square root functions are a type of radical function. The expression under the radical sign, the expression under the radical sign is called the radicand. For a square root to be a real number, the radicand cannot be negative. Values that make the radicand negative are excluded from the domain. So here's an example of a square root function. The parent function of a square root function is f of x is equal to the square root of x, and it is a curve. Its domain is greater where x is greater than 0, because we do not want the radicand to be negative. And in this case, our y, our range, is from 0 and greater. Right? So y such that y is greater than or equal to 0. That's our parent function. And if we want to go ahead and look at this example here, it says graph the function and compare to the parent graph. State the domain and the range. So we have y is equal to 4 times the square root of x. And how would we graph this? Well, we know that the domain is all x such that x is greater than or equal to 0. So we're going to go ahead and create a xy chart so we can get our ordered pairs. And we're going to start our x at 0. And we know that our x's are greater than or equal to 0, so we're going to do 1 and 2. Well, let's go and figure out what our y is when we do that. So when we substitute in 0 for x, we get 4 times the square root of 0. And the square root of 0 is 0, so 0 times 4 is 0. And so we have, when x is 1, we have 4 times the square root of 1. And we know the square root of 1 is 1, because the square root of 1 times 1 is 1, right? So then our 1 could break out. So in this case, it'd be 4 times 1. So 1 times, when x is 1, our y is equal to 4. And so now when we get to 2, things get a little bit tricky, because what we have here is 4 times the square root of 2 when we substitute in 2 for x. And so we're going to have to get a calculator for this one. So I'm punching it in, 4 times the square root of 2. And that's going to equal to 5.66. All right, so I think that's enough. We can maybe do a number 3 as well for our x value. And so let me punch that into a calculator. It's 4 times the square root of 3. And that is 6.92. So we'll go ahead and graph these. So we got 0, 0 is our first point. And then we have 1 on the x and 4 on the y. It takes us up to here. Then we have 2 to 5.66. So this is 1, 2, 3, 4, 5.66 is right about there. And then we have 3. It goes to almost to 7. So 1, 2, 3 goes to 1, 2, 3, 4, 6, 7. So right about to 7. And you can see we have this curve, right? So let me go ahead and draw this curve. It's going to go like that there. All right, so what's our range? Well, this graph is going to continue moving up, right? Just like this parent function, it also is going to continue moving up. And so the range is all y greater than 0, right? On this square root function, our range is also y such that y is greater than or equal to 0. Because you can see when x is 0, y is 0. So 0 does exist on the range. And it's going to continue moving up. So it goes up to infinity. So y is greater than 0. And now we're asked the question, how does it compare to the parent graph? Well, you could see that every y value is multiplied by 4. So it stretches upward, right? So what we can see here is that every y value is multiplied by 4. So our graph is stretched on the y-axis. Alright, so we have a vertical stretch on the y-axis. And we can go ahead and do the same thing here for 1b, but maybe I can go ahead and leave that for you to do, right? And what are we going to do? Well, we're going to start with our domain, and the domain for all of the square root functions is x is greater than or equal to 0. Well, I'm sorry, not all of them, but this one definitely is. Right? We'll see cases where it's not. But this one is. And so that's what we'll have for our domain. So when we go ahead and make our x, y chart, you're going to start your x at 0 and go to 1, 2, 3. You can add additional numbers down to 4 if you want. Plug in and find our y values, and we'll graph it. And you'll see what kind of a curve it makes. And we can determine our range and then compare it with our parent graph here.